Welcome to our review on electrolysis of molten salts. So the first thing we need to do then is understand what we mean by this term electrolysis. If we actually split up the word into electro and lysis, then electro to do with electricity and lysis is splitting. So what we're actually doing in electrolysis is splitting a chemical compound using an electrical current. In order to actually do this, we need three key things. First of all, an electrical power supply, which is usually through a power pack in the lab. We need two electrodes, which are made of metal or graphite, because they need to be able to conduct electricity to the thing called the electrolyte. And we need the electrolyte, which is a compound in a liquid state or in solution that contains mobile ions and therefore conducts electricity. So what we need to understand are there are a couple of extra terms associated here. So those electrodes that we're talking about have a specific name. So we've got the negative electrode, which is called the cathode, and that's represented over there by that angry cat being rather negative. And then we've got the positive electrode, which is the anode. Sadly, I don't have some fun picture for that one. Now, what we actually find is that the negative electrode is going to attract positive ions because the opposites will attract each other. So those positive ions are called cations because they're attracted to the cathode. Then the negative ions in our solution will be attracted to the positive electrode, the anode, and therefore they're referred to as anions. So make sure you know those four terms. So the cathode, the negative electrode, anode is the positive electrode, cation is the positive ion, and the anion is the negative ion. So what we actually see happening in electrolysis then is as those positive ions, the cations, come into contact with the cathode, then they're going to gain electrons. And when they do that, they become atoms because their charges are then balanced. Whereas the negative ions, the anions, when they come into contact with the anode, they lose electrons and still become atoms. So basically, as those ions come into contact with the electrodes, they either gain or lose electrons to become the neutral atom. So what we can actually do with our understanding of electrolysis is we can use it to predict what we will see happening at each electrode and therefore what we're going to have forming. So if we consider the case of a binary ionic compound, that's one that contains just two elements, so bi meaning two. So if we look at the example of lead bromide, it's made of lead and bromine. Lead is a metal, which means it's going to be a positive ion. So that's going to be our cation, and it will be attracted to the cathode, the negative electrode. So at the cathode, we will produce lead, because the lead ions, which are Pb2+, will then go to the cathode. They will gain two electrons, because obviously they've got to cancel out the two positive charges, hence two electrons, and then we end up with lead atoms, just Pb, no charge. At the anode, which is our positive electrode, it's going to attract the bromide ions, because bromide ions are negative. So what we'll actually find is that at the anode, we're going to produce bromine gas. So that means the bromide ions go over, they're then going to be losing two electrons, and we will make bromine gas. So what we need to bear in mind is when we're talking about this transfer of charge, we're actually talking about the ions becoming discharged. And that just means they're changing from an ion into an atom or a molecule. So what we actually see happening as a result of those ions becoming discharged is that the concentration of the ion by the electrode is going to decrease. Now, what we see happening within our reaction vessel is that other ions will move to replace them by diffusion and convection. Now, this is something that's really important to remember as to why we need them to be molten, is because if the ionic compound is a solid, then quite clearly those ions cannot move closer to the electrode. So this is why they have to be molten, which means they're melted. Now, the only other thing we need to really consider is the fact that this ties really nicely in with that whole idea about how science is sometimes held back by technology. So if we have a look, no one could have actually isolated potassium using electricity until we actually had a battery to do this. So it wasn't until Volta had invented the battery that Davy was able to then isolate potassium using electrolysis. So if we hadn't had that technological advance, we wouldn't have then had that advance in science. So sometimes what we find is that technology is the thing that's holding back our further advances in science. But when that technology comes about, science can then move forwards.